Okay, so as I was saying, if you reorient your paper so everything moves over, this is the left side of your x-axis here. That should be a negative x. This is the top of your y-axis here. And this is maybe the right side of your x-axis and the bottom side of your y-axis. So now if you look at it on the side, if you tilt your head 90 degrees there, you'll see that this point is now at -1 and -4, like that. So that point's -1, -4. So that's where this point should be. So that's what that rotation is. It's still the same distance away from the center, and it's rotated downward. So the numbers end up being the same. They're just kind of, they're reoriented, and you gave something else a negative. I mean, I could keep going. If I rotated this 180 degrees, I'd go, here's 90, and boom, there's 180. It's just over there. You do this with enough practice, here's 270 degrees, or 90 degrees clockwise. So they just keep moving that way, and they complete a circle. They're all the same distance away. The ones that are tough are the ones in between, but you won't be asked about it unless you have particulars about that type of information. So we're at -1, -4. That's 90 degrees counterclockwise about the origin. Okay, triangle TAM has vertices at 0, 5, 4, 1, and 3, 6. Find the image of this where the glide vector is -4, 0. So I'm going to glide this way for each thing. So I already drew these things up. And the line reflection is negative y equals -2. Oh, well, it's not down there. I'm at 2. Looks like I should set this up correctly next time. So y is at -2. So actually, when I reflect this, I think the triangle is going to go off the map a little bit here. But anyway, so I want to take this and I want to do a glide first. So I want to go 4 units to the left and 0 units up or down, like so. So there's my glide, which should be parallel to my reflection, by the way, and it is. So there's my glide, and now I want to reflect this across here. So since you don't have any tools, the way that you'd end up doing it, I'll take blue, is you do your individual points again. Here's that A value, 1, 2, 3, 1, 2, 3. So there's A prime. Now these other ones will be a little below, like I said, because I didn't know where that line would be. This point is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Maybe somewhere down there. And there's M prime. Oh, this should be A prime. And finally, T prime. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. About right there. I feel like I gotta sneeze. Hold it. Hold it. I might have held it. There are my dots connected. So from here, I did a glide reflection. And again, the translation and reflection should be parallel. So you should make sure that you graph that correctly. You know, it shouldn't be a vertical line right there, which is totally not a vertical line, by the way. That would be incorrect. It needs to be parallel to it. Make sure you count them right and label the points. Okay. 1 second again. I'm trying to do this without sniffling, but I think it will be impossible. Okay. Tell what types of symmetry each figure has. If it has rotational symmetry, state the angle of rotation. So here I have a nice monarch, or butterfly, whatever. Assume it's symmetrical. And we divide this right down its own line. I think on your paper it's vertical. I scanned mine, so it's a little whatever. So this is the only line of symmetry it has. It doesn't have a line of symmetry across there. It's not a mirror image. Not across there, not across there. Nowhere else but a vertical line right down the middle. So it has reflectional symmetry, or line symmetry, whatever you want to call it. Now this one does not have line symmetry. If I divide down this line, assuming that we're even, you'll see that this part kind of has that inward thing going right there, and this part stays a little rounder around here instead of having that angle. And that's the case for all these things on this tire rim. So it doesn't have any line symmetry. It does have rotational symmetry, though, if I start going around this way. Now this, again, it's a scanned image, so this won't be perfect, but let's say, like, consider a point. I'll try and see how close I can get to it. Consider a point right there. If I want to rotate it, keep rotating until I get to that point again, I got to it right there. So that's an example of, boom, this has rotational symmetry. And I got to it right there as well. And right there. And right there. And back to the top right there. So this has rotational symmetry, and it does 5 times. I take that point about the center, and I say, okay, I meet at that point here, 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 and here. So there are 5 of these central angles that are divided equally. I want to look at one of them and see how far I rotate it each time. So if there are 5 of them and it completes 360 degrees, I'll do 360 divided by 5. That's 72 degrees. So this has rotational symmetry. 72 degrees, maybe about the center. That's what you're going to say? I think we'll know what that means when we say about the center. One second. Okay, this is problematic. Okay, for each tessellation, identify a transformation in the repeating figures and list the symmetries. Okay, so here's an example of a repeating figure. All these are diamonds. I take that, this diamond pops up everywhere. It pops up here. It even pops up here. This is a diamond. It's the same thing. They're all isometries, just this one's a rotation of some sort. So there's a type of transformation that it does. So I could say it does some sort of rotation there. I could say going from this diamond to this diamond, there's a translation. So there's a transformation and a repeating figure, for example. Or it does some sort of reflection up here or whatever it is. So that covers A. You just need to do one and list all the symmetries, so each and every type. First of all, there are not any dilations. All of these are isometric. Okay, but I'll go ahead and make a cloned copy so I can do some different things. Let's see if it can reflect. Can I reflect this and end up having the same kind of stuff on it? Let's see. Let's flip it. I reflect it. Yeah, it looks like I can match it up and still kind of make the same thing with it, which you're supposed to be able to. So, okay, so it can reflect. That's cool to know. Can I translate it? Can I take this point right here and translate across somewhere? Translate downward. Yep. This has translation. Maybe up there. I can translate it, have an isometry. Can I rotate it? This one will be tough with your paper. You'll have to see it with your eyes. Rotate your head and see if you end up getting the same stuff. In this case, I can rotate this with this tool. If I rotate here, look, I end up kind of getting those same shapes. Maybe not perfect because I drew these, but there we go. There's a rotation of some sort. I can keep going. Let's see. Well, not right there. That's not the same thing. I rotate here. Okay, I get the same thing again. And I rotate 180 degrees. Boom. I end up getting the same stuff. So it has rotational symmetry. Okay, so that works out. And finally, does it have glide reflection? I think it would. I think it has. I think if it has translational and reflectional, it must have glide reflection. Here's an example. Let's take this, translate it downward like that, and then let's reflect it across something. If you reflect it across a proper axis, maybe this one, maybe end up down there. Yeah, that works. You have glide reflection in some event. You can glide it and reflect it and end up with that shape. So we can get all those. So we have translational, trans, reflect, rotational, and glide reflection. No dilation, though. These don't ever get bigger or small. They're all isometries. Okay, 2 more problems. We have a center C. We have a center 0. We have a point C. A center about the origin. And we want to dilate this with a scale factor of 10. So we learned this in class. When we have scale factor 10 in this point, this the transform point, excuse me again. Let's see. Okay. A transform point will be 10 times as far away from the center as this original point. So I'll go ahead and, I don't have to graph it first. I'll go ahead and just multiply them out. Let's take 10 and multiply it by each coordinate point. Let's say C prime is at 1.5 times 10. There it is. 1.5 times 10 and negative 2 times 10. Now I have hiccups. So this is not going to be fun. Okay, so C prime is at 15 and negative 20. Hiccups, sniffles, and this is just impossible. So it's at 15, negative 20. Let's go over 15 and down 20, and there's C prime. And to double check, it should be... Oh, God. it should be